This is my fifth video lesson for the unit Atomic Theory. Today we're going to talk about the excited state of an atom. So go to page 16 in the class packet. Motivation. Below show two models of neon atoms. What are three similarities and three differences about the two models? Okay, so I'll pause the video and resume once you have done it. Okay, so let's read the learning target first. At the end of the lesson, I will be able to identify and write a possible excited state of an atom. So for announcements, be homework number 5, which is a Junipod. So let's go over the motivation. Let me first write out the electron configuration of each of the atoms. The similarities between these two atoms are they're the same element, right? They're both neon, and they both have 10 electrons. That means both of these are neutral. There's no ions here. And they both have a positive nucleus. Now, what's the difference? So the electron placement, notice that the configuration is different. One is the ground state, and one is not the ground state, okay? One has 2 energy levels, one has 3. So since this one over here is not the ground state, this one is called the excited state. Excited state configuration is an atom with an electron that has been moved to a higher energy level by absorbing energy. So let's look at a model. So here we have an atom in the ground state. An electron gains or absorbs energy, right? Then the electron jumps to a higher energy level, and we call that an excited state of the atom. Notice that the electron was in the first energy level, now is on the second. If an atom is excited, the total energy of the electrons can be lowered by moving one or more electrons to a different energy level. So what does this mean? It means that in an excited state, you can always lower the energy of that atom, okay? Because it's not the ground state. For example, in this model, if I were to lower the energy, I will move this electron back down. So let's look at model 2 now. So here we have an excited state atom. If the electron were to release energy, right, it will go back down, and this will be the ground state, okay? So when an electron in the excited state releases energy, it moves from a higher energy level to a lower energy level, as you can see here. Check of understanding number 1. Why might an excited atom return to the ground state? One way to think about this is that an excited state is unstable. Ground state is stable, right? It's the lowest possible energy. It cannot get lower than that. So you may notice that when things are unstable, they eventually will become stable, okay? So something to keep in mind, the excited state is not the lowest energy state of an atom, okay? So how can we excite atoms? So there's a couple of ways: heat, electricity, light, and collisions, okay? So here's a GIF of what's going on. So you can see that green arrow was energy. So here's the electron releasing energy. It goes back to the ground state. If it absorbs energy, it goes up. Learning check number 1. When an electron in the ground state moves to the excited state, the electron does what? So pause the video and resume once you have the answer. Okay, so the answer is 1. Absorbs energy as it moves to the higher energy state. Okay? So now we're going to focus on identifying excited states. So here are 3 guidelines. Number 1, not the ground state and is not on the reference table. Number 2, number of electrons stay the same. Number 3, cannot have more than the max electrons in a shell. Okay, so let's do an example. Ground state of sulfur, if you look it up, is 2-8-6. Now, here are possible choices of an excited state of sulfur. Let's look at the first one. Does the first one fit all 3 guidelines? The answer is yes. Okay, how about the second one? So this one has 17 electrons. Sulfur has 16. So this one cannot be an excited state of sulfur. How about the third one? So notice this one has 16 electrons, but this one's also not the excited state of sulfur. Why? Because this is the ground state of sulfur. How about number 4? Yes, it fits the guidelines. How about number 5? Notice that for number 5, the second shell has more than 8 electrons. That's impossible. So this one's wrong because of guideline number 3. Okay, how about number 6? Number 6 looks kind of tricky. So it is following guideline 1, 2, and 3. Therefore, this one is an excited state of sulfur. Learning check number 2. Which electron configuration represents the electrons of an atom of neon in the excited state? So try to do this yourself, pause the video, and resume once you have the answer. Okay, so the answer is choice 3. Okay? Which electron configuration represents the electrons of an atom in an excited state? So notice you don't tell you any element. Okay, so try to do it yourself, resume once you have the answer. So the answer is choice 3. Notice that for choice 3, the second shell is not filled. So you will not find this configuration anywhere on the periodic table. Okay, so now I want you to do some practice problems. So try to do the first table on your own. Resume the video once you have the answers. Okay, so here are the answers for neon, phosphorus, and chlorine, and for the excited states of those atoms. Okay, so for the second practice, you're going to put a check mark if the following configurations are ground states or excited state. Let me do the first two. So the first one, that's an excited state. The second one is a ground state. So do the rest on your own. Pause the video and resume once you have the answer. Okay, so here are the answers. Okay, so now we're given an element. I want you to write the configuration of the ground state and give a possible excited state configuration. So do it yourself, pause the video, and resume once you have the answers. Okay, so here are the answers. So this concludes the video lesson for today. Remember to do the Junipod homework.